So hello everyone, welcome to this new session. So we are going to start in this session with the new module, that is the fourth module. The name of the module is Ordinary Differential Equations of Higher Order. Okay, so we are going to study about the ODE'S, Ordinary Differential Equations, but of some of the higher orders. Okay, yeah. So we have some concepts related to this module that we are going to discuss right now. That is, the first thing, let's see the linear differential equations of higher order with higher coefficients. Okay, we know that generally differential equation is of the form a naught, where d power n y divided by dx power n. That is, this is generally the nth derivative. Okay, and this is the next derivative of the, means if for example n is equal to 3 here, plus the next derivative would be written as square, right? So 3 minus 1 d square y by dx square, like that. This is the general form of the differential equation, where a naught, a1 up to an are all constants, and they are called a linear differential equation of nth order. See, nth order with constant coefficients. Okay, so here a naught, a1 up to an minus 1 are the constant coefficients. Okay, so for this, let's take an example of a linear differential equation. See, here 4, 2, and this is 1 here. These all are constants, and along with the highest degree here. See, we can see that d cube y by dx cube, plus when we write the next term, now the degree would be reduced, but that degree is not mentioned because the coefficient here is t square y by dx square. See, this is a general differential equation. So this linear differential equation is of the order 3. See, means the highest degree here is 3, right? So we can see that it's of the order 3. Using the notation d by dx is equal to d, and d square by dx square is equal to d square, up to d power n by dx power n up to d power n. The above differential equation can be written in the form of, so we have just done one change, that is, wherever there is a d cube by dx cube, right, in place of that we have replaced it by the small letter, capital letter d cube. Okay, so the above differential equation now would be represented in the form like this. See, wherever there is a dn power d, or dn divided by dx power n, that is replaced here by capital letter d power n, capital letter d power n minus 1 up to a n minus 1 dy. Okay, where d here, the capital letter d is called the differential operator. Okay, yeah. So now let's see a few more topics, that is homogeneous differential equation. So in a given differential equation, so we write it as, see here, take an example of this differential equation. This is not a homogeneous equation, since whatever is there here, right, after a differential equation equal to whatever we write here, right, this is r of x, we call it as r of x. Okay, but in case of homogeneous differential equation, always the value of r of x is equal to 0. Okay, the value of r of x is equal to 0. But in case of a non-homogeneous equation, where we are going to discuss further, the r of x would be having some value. Okay, in remember that in homogeneous equation always the value of r of x is equal to 0. Okay, this was all about homogeneous. And again it's written here, see, if r of x is not equal to 0, then we say it as it is a non-homogeneous differential equation. So now let's discuss about how to write the general solution of this homogeneous linear differential equation. Okay, so consider the homogeneous differential equation of order n, where f of d of y, that is the function of d, is equal to r of x, where r of x is equal to 0. I have told you, right, in case of homogeneous equation the r of x is equal to 0. Therefore the f of d, the function of d, is equal to 0, where f of d is a polynomial in D of degree n, and consider the equation f of m equal to 0. Whenever, the first step what we need to do is, whenever the function f of d is equal to 0, first we need to replace all the d by m terms, and whatever this f of m is called, right, that equation is called as an auxiliary equation. Okay, you will get to know it clearly while doing the problems. Okay, yeah. So now in order to solve these kind of problems, these homogeneous equation problems, we have these three cases. Okay, so after writing the auxiliary equation, we are going to get a quadratic kind of equation. Okay, in that quadratic equation we are going to apply the quadratic formula and we are going to find the roots of the equation. Okay, you might be knowing that in case these are the roots here, see m1 m2 up to mn, in case if whatever the roots we get, all of them are equal. For example, in an equation, if you got the roots as 1 comma 1, two roots as 1 comma 1, since these two roots are same, right, we can represent it in a general solution as c1 plus c2x plus c3x square up to cn x to the power n minus 1 into e power mx. Okay, this is the way we write the equation. So this is the first kind of case, how to solve. So in the second case also, if suppose m comma m1 comma m2 comma up to mn are n distinct real roots of the auxiliary equation f of m equal to 0. If means if the roots are not the same, if the roots are discontinuous, for example, if the roots we get in an equation as 1 comma 2 comma 3, for that case we are going to write it as c1 into e power whatever the root we got, that is m1x. For example, here the first root here is 1, right? So we are going to write the general solution as c1 into e power x plus c2 into e power 2x plus c3 into e power 3x. So this is the way we are going to write the general solution. So in this module, all thing we need to write is the final solution which we get is we need to write it in the form of a general solution. Okay, yeah. So suppose if the roots of the auxiliary equation, this is the third case of the auxiliary equation, f of m equal to 0 are complex conjugates. For example, it is of the form of alpha plus or minus I beta. Sometimes we get, right, if the root inside is a negative number, we get the final root in the form of this. For example, let's take 1 plus or minus square root of 3i. Okay, if the final root which we get is of the form of this form, in that case we are going to write the final general solution in this form. Okay, c1 cos beta x plus c2 sin beta x whole bracket e to the power alpha x. Okay, where here we can see that this corresponds to alpha plus or minus I into this corresponds to beta. So let's try to write the general solution for this. Let's take an example. It's according to the formula c1 cos, here whatever we have beta, that is root 3, right, root 3x plus c2 cos, again beta is root 3x into e power alpha is here 1, right, e power 1x. Like this, in this way we are going to represent it. This is the third case. Okay, yeah. See, we have some of the examples here. See, they have given roots, along with that they have given some of the roots. See, if the roots here are 1 comma 3, we represent the general solution in this form. See, c1 e power x, see, e power m1x, right? So this is 1 and here this is 3. If the roots are 1 minus 1, 3 minus 3, then we represent it as c1 e power x, where the coefficient of x is 1, first root, and here the second root here is minus 1, third root is 3, and the fourth root is minus 3, along with c1, c2, c3, c4. Okay, the same thing. See here, for the imaginary terms we have here these two examples. 3 plus or minus 2i, here alpha is equal to 3 and beta is equal to 2. See here, c1 cos beta x, right, 2x into e power alpha x, where alpha corresponds to 3. Here also 1 comma plus or minus 3i, this is not together, 1 comma plus or minus 3i. See, if the root is here is 1, so how we write it in general form, that is c1 e power x, plus if there is c1, when we write plus we need to continue it. Okay, we cannot write it again as c1 since the term here is different, right? The plus or minus 3i, which is alpha and which is beta, here we can see that beta is present, right, beta, but where is alpha? If there are no numbers here, we can call it as it is 0. Okay, yeah, this is actually into e power 0x. We know that e power 0 is equal to 1, right? So this term gets cancelled. Okay, yeah. So these are some of the examples. So now let's solve problems so that you will be very clear about the concepts. Okay, you will be very clear when you solve the problem. Okay, you will understand how these roots and all appears, how these three cases react. Yeah, so now we'll solve the problems. So this goes the first problem of this module. So the given problem is d cube y by dx cube minus 2 into d square y by dx square plus 4 into dy by dx minus 8y equal to 0. For this now we need to find the general solution. Okay, yeah. So the first step here is we can see that there are d cube, dx cube, d square, dx square, d and dx. These three things we can replace by capital letter, right? So how we can write? So first thing we need to do here is wherever there is d cube by dx cube, write it as d cube, capital D cube y minus 2 into capital D square y plus 4 into capital dy minus 8y is equal to 0. This is homogeneous type of problems, okay, since r of x is equal to 0, right? Yeah. So here in all the terms y is common, take that outside, that is d cube minus 2d square plus 4d minus 8 into y is equal to 0. Okay. So now whatever is there in this bracket, right, this corresponds to f of d. Okay, f of d means the function of d. So now we need to replace it by f of m, where this f of m is called as auxiliary equation. Okay, in order to solve these kind of problems, the first thing we need to do here is replace f of d by f of m. So now while replacing f of m, this y gets vanished. Okay, so now let's replace f of d by f of m, that is wherever d is there, replace it by small letter m, so that d is equal to m. Now it becomes m cube minus 2m square plus 4m minus 8 is equal to 0. So now we know that if it is a cubic polynomial, for that first thing we need to apply is the inspection method, right? First write the coefficients of all these, that is 1 minus 2 plus 4 minus 8 plus 4 minus 8, and after that we need to write the equation in the calculator, and we need to check that which m term, which m value, when we put it in the calculator it is equal to 0. Okay, so now let's check it. Okay, yeah, so I am going to write this equation now. So since I can't write in the variable m is not present in the calculator, I'll use the variable x. Okay, so how to write x in the calculator? See, I am going to show you now. We need to press alpha along with the close bracket, okay, so that we get x. See, we got x. We need to press alpha, after that we need to press the close bracket. After that write the degree, that is x cube, right, minus 2 into x square plus 4 into x minus 8. After this step we have put the equation in the calculator right now. Now press calc button. You might be having calc button. This version is 991 ES. Okay, in other versions also you might be having it. Now press this calc. So now it asks to enter the value of x. So the first value, let me enter it as 0. Now if I enter the value 0, I need to press the equal to sign. Now press it. So the answer we are getting here is minus 8, but our goal is this answer should be equal to 0. Okay, so we know that now first root we have found that it is 0. So in 0, if we put the value x equal to 0, we get minus 8. So now again press the equal to sign. After that it again asks the value of x. Now 0 is done, right? Now let's put the value of x as 1. See, the answer we get is minus 5. Again it's not equal to 0. So now after 1, it's better if you put the value of x as after 1 as minus 1. Okay, there might be the chances that a negative value also might be, the equation would be equal to 0. So now again press equal to sign, put the value of x as minus 1. Again the answer here we got is minus 15. Again press the equal to sign. Again it asks the value of x. Now 1 minus 1 is done. Now put the value of x as 2. Yeah, see, now if we put the value of x as 2 in this equation, we get the we get the final answer as 0, right? So that's all. The first thing in this equation, the first root we get is 2. That we need to write is here. Okay, this is our first root, that is m equal to 2. Now the first number bring it down as it is. So now we need to multiply 2 to this number whatever we have written in this line. Okay, 2 into 1 here is 2, so write that 2 here. Okay, so now we need to add these two. So by adding plus 2 minus 2 is equal to 0, and 2 into 0 is 0, 4 plus 0 is 4, 2 4s are 8, minus 8 plus 8 is equal to 0. See, the last value I got here is 0, right? It should be equal to 0. Okay, so now using these coefficients, write the equation, okay, of m model, f of m. Okay, so now f of m would be equal to m square, where the coefficient here is 1, plus 0m plus 4 equal to 0, right? So now again we can write it as m square plus 4 equal to 0. So now we can solve this without using the quadratic formula only, because the value here is b equal to 0, right? So if we bring this 4 to other side, it will be m square is equal to minus 4. Okay, so m would be equal to plus or minus square root of minus 4, m equal to plus or minus square root of 4i square, right? See, if the value of I square it is equal to minus 1, so I have just in order to neglect this minus sign, I have put the value of minus 1 as I square. So m equal to plus or minus square root of 4 is 2 and I square is I. So we get the two roots as, so the total roots which we are getting for this equation are, first root we got is 2, right, comma plus or minus 2i. So now we got the roots. So now we are going to write the general solution, that is, therefore general solution can be written as y is equal to, first root is 2, right? So it can be written as c1 e to the power whatever the root we got, 2 into x, plus, now c1 is done, so write c2, and here the value of this is the value of beta and the value of alpha here is 0. So c2 cos beta x, so value of beta here is 2, plus c3 sin beta x, again 2, whole bracket e to the power alpha x 0x. We know that e to the power 0 is 1, so the final answer which we are getting is c1 e to the power 2x plus c2 cos 2x plus c3 sin 2x. So this is your required general solution. So in this way we need to solve this problem. Okay, yeah, so we'll get to the next question. So this is your next question, the second question, that is d cube y plus 6d by dx cube plus 6d square y by dx square plus 11 dy by dx plus 6y equal to 0. So now replace all the d cube by dx cube, d square by dx square terms as capital letters. So it will be now d cube y plus 6 into d square y plus 11 into dy plus 6y equal to 0. So y is common in all the terms, take that outside, so the remaining terms are d cube plus 6d square plus 11d plus 6 whole bracket y equal to 0. So this is the corresponds to f of d. So now we need to replace it by f of m, that is the auxiliary equation, right? So now f of m would be looking like this, that is, wherever d is there, replace it by m cube plus 6m square plus 11m plus 6 is equal to 0. So now here since it's a cubic polynomial, again apply the synthetic division method, write all the coefficients 1, 6, 11 and 6. Again we need to find the first root, that is, put this equation in the calculator, alpha and close bracket x cube, right, plus 6 into x square plus 11 into x plus 6. Okay, press the calc button, it asks the value of x, first put the value of x as 0, we get it as 6, we need to, our goal is to get 0 here, so again press equal to, again it asks the value of x, now put the value of x as 1, it gets 24, again press equal to, now put the value of x as minus 1, see, for minus 1 we got the value of this equation equal to 0. So the first root here is m equal to minus 1. Okay, so now the same thing, bring this one down, multiply this one with this one, that is minus 1 into 1 is equal to minus 1. 6, we need to add this 6 plus minus 1, so 6 minus 1 is 5, minus 1, 5 is minus 5, 11 minus 5 is equal to 6. Minus 1 into 6 is equal to minus 6. So 6 minus 6 is equal to 0. See, we got the final last root as 0. So using these coefficients, write the f of m, that is m square plus 5m plus 6 equal to 0. So now we have the quadratic equation. So now for this, use the quadratic formula, that is the formula goes like m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. We have used this formula many times, right? Yeah, so now same thing we are going to do it here. Here the value of b is 5, right? Plus or minus square root of 5 square, it is 25, minus 4 into 1 into 6. 4 6 are 24, divided by 2 into 1 is 2. So m is equal to minus 5 plus or minus 25 minus 24 is 1, and square root of 1 is equal to 1 by 2. So the value of m is minus 5 plus 1 by 2 or minus 5 minus 1 by 2. That is minus 5 plus 1 by 2 is equal to minus 4 by 2, or minus 5 minus 1 by 2 is equal to minus 6 by 2. 4 2 1s are 2 2s are 2 1s are 2 3s. So the roots we are getting is minus 2 comma minus 3, right, for this quadratic equation. But the total roots we got here is, for this whole cubic equation, the first root we got here is minus 1, right? Minus 1 comma these two roots. So here we can see that the roots are not the same, it's are changed. For that we need to use the second case which we have discussed, that is the general solution can be written as c1 e to the power, the first root is minus x, right? Coefficient of x here is minus 1, plus c2 e to the power minus 2x, second root, c3 e to the power minus 3x. So this is your required general solution. Okay, so we have a few more problems, let's discuss them. So this is the third problem, that is 4y triple dash plus 4y double dash plus y dash is equal to 0. So what is this triple dash, double dash? These are the third derivative. This triple dash represents to third order derivative. This is second order and first order. This also can be written as 4 into d cube y by dx cube plus 4 into d square y by dx square plus 4 into dy by dx is equal to 0. Okay, so now let's replace all the d cube by dx cube, d square by dx square, d by dx as 4 into d cube y plus 4 into d square y plus dy, this 4 is not there here, yeah, is equal to 0. So now here y is common, take that outside. 4d cube plus 4d square plus d is equal y is equal to 0. Yeah, so now let's replace all the d terms by m terms, writing replace f of d by f of m. So f of m, now it is equal to 4m square 4m cube plus 4m square plus m equal to 0. Again this is of the form cubic polynomial, right? Again write the coefficient, that is 4 4 1, and there is another constant term, right, which is not mentioned, so we need to write that as 0. Okay, again the same thing, put the equation in the calculator to find the first root, that is 4x cube plus 4x square plus x. Okay, hit the calc button, it asks the value of x, put the first value of x as 0. Yeah, see the first root we got is m equal to 0. So now again bring this 4, 0 4s are 0, 4 plus 0 is 4, again 0 4s are 0, 1 plus 0 is 1, 0 1s are 0. Yeah, so we got these three terms. So now in this, let's write the quadratic equation, that is 4m square plus 4m plus 1 is equal to 0. So now apply the quadratic formula. M is equal to, the value of b here is 4, right? So minus 4 plus or minus square root of b square, that is 4 square is 16 minus 4 into a into c, that is 4 into 4 into 1, again it is 16 divided by 8. 2 4s are 8, right? M is equal to minus 4 plus or minus 16 minus 16 is 0 by 8. So the value of M we are getting is minus 4 plus 0 by 8 comma minus 4 minus 0 by 8, again which is equal to minus 4 by 8 comma again this is minus 4 by 8. So the 4 1s are 4 2s are 4 1s are 4 2s are. So these two roots are repeating here, minus 1 by 2 and minus 1 by 2. Okay, so the total roots which we got here is 0 minus 1 by 2 comma minus 1 by 2. So now using this we need to write the general solution. Y is equal to c1 e to the power, first root is 0, so 0x plus c2 e to the power minus 1 by 2x plus c3 e to the power again minus 1 by 2x. But we know that for distinct roots, if the roots are repeating, we can write it as y is equal to e to the power 0x is 1, right? So only c1 remains here, plus for if the roots are repeating we can write it as c2 plus c3x. Only two roots are repeating, right? 2 times, so bracket e to the power whatever the root is given that. Yeah, so this is your required general solution. Okay, so that's all for this session. So in the next session we are going to continue with these kind of problems. Thank you.